Hey guys, how's it going? So in this tutorial I'll be showing you guys how to use JMOL to plot or visualize the molecular orbitals generated through software such as Quantum Espresso, TurboMol, Gaussian, etc. in the CUB file format. So in the last tutorial I already made a video or showed you guys how to install or rather download and run JMOL on Mac OS, Linux, Windows, etc. So the process is pretty much basic. You just download this JMOL directory or package, and then just extract the contents and then try to run jmol.jar. And if you are not able to run it, then basically it means you don't have the Java runtime environment. So you just go ahead and download that and install it, and then you should be able to run it. So anywho, coming back to the tutorial, so just go to the JMOL directory, wherever you placed it on your PC or computer, and then just go ahead and launch this jmol.jar file. So it will open the JMOL window, as you can see over here, and now we'll try to plot the molecular orbitals that we generated using Quantum Espresso, as I showed you guys in one of my previous tutorials. So I'll just go ahead and open this directory called benzene, where we performed some calculations in that tutorial and generated the highest occupied molecular orbitals and the lowest unoccupied molecular orbitals for benzene. So the once you have the .cube files for the molecular orbitals generated through any of the softwares, any of the DFT softwares, or molecular chemistry, or whatever you want to call it, then all you need to do is you need to click on the file, the .cube file containing the molecular orbitals, and then drag them onto the JMOL window, and you'll be able to see something, and maybe you won't be able to see anything, but in some cases you will see a good molecular orbital. But in case you don't, then don't worry, it's normal. What you need to do is you need to right click on the JMOL window and open the console, or you can even open the console by going to the file and clicking on console. So the major advantage with JMOL is that it allows you to script, and you can basically write great scripts, such as you can write a script to calculate the center of mass or design something, and even tweak some of the default features like the molecular orbital drawing. So once you're in the console, like in a regular terminal console, if you press the up arrow key, then you will be able to see what was the previous command. So when we dragged over this file over to the JMOL window, then JMOL used this command to draw this isosurface, what we are seeing here. But it is obviously not correct. So first of all, you should never just use this command directly to load up a CUB file, because it will only draw the molecular orbitals and not the atoms. But if you go ahead and open the CUB file using a text editor, then what you'll notice is that it is not only containing the molecular orbital information, but essentially in the starting it also contains the atomic coordinates. So basically 1 means the hydrogen atoms and 6 means the carbon atoms, and then there are the coordinates for all these atoms in atomic units or Bohrs, and then you have some information about the grid over which the molecular orbitals are plotted, and then the value of the molecular orbitals or the wave functions at the grid points. So this is basically what a CUB file looks like. So when you use a CUB file, you should also be able to see the atoms. So what we are going to do is, coming back to the JMOL console, so we are going to press the up key, and which will basically help us get the address of this CUB file, and then we will delete all this stuff like isosurface sign red blue and write load over here. So what this will do is it will load up the CUB file, but only the atoms from the CUB file. So it will load up the atomic model or the molecular model, and then what you can do is you can go to press the up key to see the previous commands in the history, and then give a command such as isosurface sign red blue, and then the address of the CUB file within inverted commas. So what this basically means is it will draw an isosurface, which is essentially the molecular orbital in our case, but even electronic densities which are in CUB format can be drawn using the isosurface command. So isosurface sign red blue basically means isosurface I already explained, and then sign red blue basically means that the negative wave functions are drawn in red color, while the positive wave function are drawn in blue color. So if at some point in space the value of the wave function is negative, then it will be, you will see a red blob kind of surface around it, while for positive values you'll see blue. And then the address. So this is basically self-explanatory. So, and now if you press enter, you will see that something appears onto the atoms, but not exactly what you call a molecular orbital. But don't worry, the key to that is the different ways in which molecular orbitals are generated in different softwares. So if I had generated these using some software such as Gaussian and or any other software which for molecular orbitals, which what they do is they give the value of psi, which is the wave function. But what quantum espresso does is, contrary to several other molecular programs, is that it gives the value of psi square, that is the square of the wave function. Therefore, since wave function is already really small, less than 1 at a number of grid points, so when you give when you try to calculate the psi square, that is the square of the wave function, then the values get even smaller. So therefore JMOL isn't tuned to plot psi square, it is more tuned to plot psi. And since quantum espresso is generating psi square values, therefore it is cutting off a lot of values. So what basically JMOL does is it uses a parameter called cutoff, and you can change it. So that is the good thing about JMOL. So although it is cutting off a lot of our wave function originally, but you can change that and give this command cutoff and some value after it, such as 0.001 and then space, and then hit enter. And now what you can see is really good molecular orbitals being drawn for the I believe it is the highest occupied molecular orbital for benzene, or maybe we can check it, because I'm not really sure if I generated them correctly or not, or rather I named them correctly or not. So here it is. Let's see. Okay. So yeah, actually those are the LUMOs, not the highest occupied molecular orbitals. I'm not sure why I named them like HOMO, but that is actually LUMO, which is why I was getting rather confused and decided to check. So yeah, this is the LUMO. It doesn't matter what I named them, because I'm probably I made a mistake while naming them. But yeah, so sorry. So this is how you will generate molecular orbitals on using JMOL. So the first thing is you load the CUB file using the load command, as you can see over here, and then the address of the CUB file within inverted commas, and then you can use the command isosurface cutoff, and then the signs of the positive and negative parts, and then the address of the CUB file within inverted commas. Now one more thing that you can do is you can change the colors. So it is not necessary to use red or blue. You can use anything you want, like green, yellow, and it will work like that. So now you are seeing a different view, and you can even make these orbitals transparent by giving the by adding the keyword translucent. And now you can see that the molecular orbitals are transparent or translucent, and you can see the atoms as well. And you can even change the translucency by giving the parameter or keyword translucent and then a value between 0 to 1. So 0.5 basically is like 50% translucent. So let's see if we make it 0.7. So as you can see now, it is even more translucent. Let's see if we can make it even more. 8.7. Yeah, so it is getting even more translucent. And you can also, instead of using these point values, you can also give values on a scale, integer values on a scale of 1 to 10. So in that case, 9 will correspond to very transparent, and then 1 would correspond to very not transparent. So yeah, so this is how you would be using the isosurface command of JMOL to plot the molecular orbitals or visualize them. And also let's take as an example some calculation I did with TurboMol, and where is it? Okay, so here it is. So in TurboMol, if you plot the molecular orbitals and then just drag the cube file over the JMOL window, and yes, click on yes when it asks you if you like to replace the current model. So yes, then what you'll notice is it has the previous atomic structure or molecular structure as well as the orbitals from read from this cube file. So of course what you should do is you should first of all delete this particular isosurface by giving the command isosurface delete, and you should also like get rid of this molecular structure. So in order to get rid of this, as I already told you, use the command load instead of isosurface. So the command, or rather the address of this particular molecular orbital is this, and we'll just use load in front of it rather than isosurface. So write down load and then the address and then hit enter. So what it will do is it will load up the coordinates from this particular cube file, and then now you can use the command isosurface with the address of this particular cube file and also sign red blue. But now what you'll notice is even if I don't give the cutoff, it is still reading the molecular orbitals in a pretty good fashion, and considering that it is a very low-lying molecular orbital, it is correct and it is reading it correctly. And if you want to plot the the LUMO as we did in the previous case, then you should load up this one, that is the 22nd orbital. Yeah, and yeah, it is, as you can see, this time we are able to load it correctly even without specifying the cutoff. Now the reason why this is happening is and also you are noticing that this time I don't have to give the load command, and I'm just dragging them over here, and when I press the up key it just gives the isosurface command. It is correctly loading all those. Now this is happening because since all of these cube files are generated for the similar structure or the exact same structure, therefore the coordinates are still remaining the same, and therefore if you only plot the isosurface, then that also looks correct on the structures. And the reason we don't have to give the cutoff is because this software plotted the psi, that is wave function value, which were between 0 to 1, so they are considerably larger than psi square. So that is why the cutoff is pretty high, and JMOL is able to use its default cutoff to display everything, although you can still play with the cutoff and like use 0.1, and now you can see that the molecular orbitals are significantly inhibited. And also one more very important thing that I should mention here, and I should have mentioned before, was you can even also plot only the positive and the negative contributions to the wave function. So in order to plot only the positive wave function, you can use the command like so what you'll do is you'll get off this sign red blue because you're only going to be plotting the positive or the negative part. And then since 0.1 is too high, we'll use something like 0.05, and we will use a plus sign over here. So what this will do is it will only plot the molecular orbitals greater than plus 0.05. So we'll get only the positive molecular orbitals. So as you can see, we are getting only half the molecular orbitals as we are getting in the previous case. And then you can also plot the negative contribution separately by using the command isosurface cutoff minus 0.05. And this time you will notice you are getting the other half of the molecular orbitals, which are negative. So this can be useful also for your research papers if you want to do or plot them separately. And also with JMOL you can change the color of the background to like white so that they look a little bit nicer. You can increase the JMOL window size, and then right click over here and click on file and go to export, and export it as a PNG image or a POV ray image. And POV ray images are then to get the image from the POV ray, you will have to use the software POV ray, which I'll probably make a video about. And then you can even export these as 3D models. for use in external programs like Blender. So you can even 3D print out these molecular orbitals models, or you can use the Blender program to create even more stunning or graphically more higher quality molecular orbitals for research papers if you export these as a 3D model and import them in Blender. So that is pretty much it, and you can also right click here and click on surfaces and click here to make them translucent, and also you can right click again on the window and then click on surfaces and click here to make it opaque back. So that is pretty much everything you need to know about plotting molecular orbitals. And also make sure or remember that same things do apply for density as well. So if you're plotting electron densities or charge densities then and have a cube file with you, then everything should be pretty much similar to what we have discussed in this tutorial. And you can, there are a lot of functions which I've already discussed in another video, so you can have them spinning, or maybe just plot both the molecular orbitals at once and make them translucent, and you have a nice little thing going on here. So that is it. That is how you use JMOL to plot CUB files containing molecular orbitals or electronic densities. Hope you guys enjoyed this video. In case you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. Thanks for watching and have a great day.